What's up, chasers? A major shift in the weather pattern across the United States is about to take place, and it's going to bring with it the threat for severe weather. Throughout this next week, the Midwest and the Southern Plains could see multiple rounds of storms, some of which may become severe. These threats include, but are not limited to, high winds, large hail, and even a few tornadoes. In this video, we're going to break it down exactly what is happening in the atmosphere, where the greatest risks are setting up, and what you need to know heading into this week. Looking at our SPC outlook, we can see that they highlighted a slight risk in the Great Lakes region, and with this included a hashed 2% risk for tornadoes, a 15% risk for wind, and a 15% risk for hail. So taking a look at our upper level charts, we can see we have this shortwave trough right here, which is going to serve as kind of a proxy for lift and the driver for a lot of these storms. And it's going to move eastward with the storms as we go throughout the day. Looking at our 200 millibar wind chart, we can see that we're in the right entrance right here, which is a good proxy for more lift. So all of the upper levels are agreeing that we're going to see lifting and divergence where we need it to be. Looking at our surface chart, we can see we have this surface low pressure system right here, which has a cold front, which is going to be our surface lifting mechanism. And we can see that it is going to be moving eastward as the day progresses, bringing that cold front and those storms with it. As we can see outlined on this theta E chart, we have the cold front right here, and it is going to continue to propagate eastward as that low pressure system takes it with. While the cold front is our main lifting mechanism, the low level jet will also serve as a secondary lifting mechanism above the front, where we have areas of convergence over the front area. Now, to understand our daytime heating, we can see that we have lots of cloud cover thanks to all of those lifting mechanisms we previously discussed. And as the day progresses, we'll see a couple patches where the sun can peek through, but other than that, daytime heating is going to be fairly limited due to the overcast conditions. Looking across the whole column, we see we have high values of precipitable water, plenty of which above 1 inch, which as we move on through the time, we can see that we have values all peaking all the way above 1.6 inches. That's plenty of moisture in our column. Taking a look at our instability and our shear, starting with the photographs, we see a lot of these clockwise rotation, which is a good indicator of directional shear and a good proxy that maybe some tornadoes are going to spin up within these storms. Now, we don't have a lot of high CAPE values at the start of this, but as we progress through our time, we can see that the CAPE values start to reach above that 1,000 joules per kilogram, with the easternmost regions even peaking above 2,000. Now, looking kind of closer at where some of these storms are going to develop in the 1,000 region, we can see that by 22Z, we're already well past our cap. And then our temperature getting up to 80, there's plenty of chances for lifting as it is free convection from here. Now, looking at our surface temperatures, we can see that as we progress through the time, our highs are going to reach into the low 80s, which means that all of our regions are roughly going to break through that cap, which means there's going to be lots of room for free convection as we have those lifting mechanisms in place. Now, kind of understanding some of the timing of these storms, and with this one model run, we can see that by 15Z, we already have some of these storms in the western area of our region. But as they move over more of our lifting mechanisms into more of the ingredients, we can see that they're going to start building. And in this picture, we can already see that there's a couple areas where some pop-up spin-ups might occur. Now, as the storms continue to propagate further east, they're going into the more cape-rich environment, which is going to allow these storms to sustain themselves further. Now, while the thunderstorms are going to continue into the night, after sunset, we're going to lose that daytime heating, and that's when the severe risk is going to end.
So going back onto Tuesday, we look into the Oklahoma and Texas areas. We can see that the SPC has highlighted a marginal risk of severe weather across central and western Oklahoma into the Texas Panhandle, with the main threats being a wind and a hail risk in this area. Now, the tornado risk cannot be ruled out, but the risk is fairly conditional, and we will see why in a moment. Taking a look at our four panel, and the top two panels, on top left and top right, we are looking at our mid and our upper levels. We can see a short wave passing through our area slightly off to the north compared to previous runs. Now, we see that Tuesday evening into the overnight hours, we could see an overnight nocturnal severe threat. as we have continued flow off the Gulf, advecting moisture and warm air into the region. Now, it should be noted that there is some model uncertainty with the intensity and the area of where these storms will fire and the timing of it, but we will get more into that in a moment. So now taking a look at our surface dew points, we can see a clear dew point gradient here, indicating the presence of a dry line. This dry line will be our primary mechanism along with the shortwave that is passing through our area. However, on recent model runs it appears to be passing slightly further north. Now, modeling does have generally pretty good agreement with the location of the dry line, but there are some variations of the dew point in the risk area. If we take a look at the current model runs and compare them at this time, we can see the GFS has dew points in the mid 50s, the ECMWF has slightly higher dew points in the upper 50s, the NAM has slightly higher dew points as well in the upper 50s and some areas in the lower 60s, and just in general some slight variation here, but you get the point. Now, the biggest question with our setup in the western Oklahoma and Texas Panhandle region is whether convective initiation will actually occur or not, and this will ultimately depend on whether we break through the cap. If we take a look at some modeled soundings from the HUR, we see in our risk area we have quite the inversion in the low levels and an area of SIN, which is preventing storms from firing earlier in the day. Now, this will ultimately come down to whether synoptic forcing is great enough to be able to break through the cap. If we take a look at the CAPE values throughout our area, or even across the country, we can see a boundary located here. Now, this dry line right here will be our main lifting mechanism. And taking a look at CAPE values through the area, we can see that in 1819Z, we have values around 1500 joules and growing to near 2000 by the early evening hours. Now, looking at our sounding once again, we can see that we still have a slight cap here, but great instability above, and the big question once again is whether or not we can break through the cap. If we can break through the cap, we would anticipate a large hail risk along with potential damaging winds. However, looking at our LCL and low-level SRH, we can see that the tornado risk will probably be very low. While this event is less than 24 hours away, the SPC has noted that there is uncertainty with the setup, and that storm initiation and coverage will be dependent on the position and the depth of the shortwave trough as it passes through. Strong diurnal heating with steep lapse rates along the dry line should promote isolated thunderstorm development by the late afternoon into the evening, but there are still a few questions based on the presence of dry air and weak forcing. Now, if we go to a sounding within our time frame in our region, we can see that we do have some dry mid-level air here, which could inhibit the development of storms, or if they do develop, they could die off very quickly. Now that we've gone through all of the ingredients going into our setup for tomorrow in the Oklahoma and Texas Panhandle region, we're going to look at what the simulated reflectivity of the HUR has to say. Now, it is important to realize that the HUR is just one model run, and that things can probably not going to go exactly as plotted here. Now, the HUR has initiation beginning in the western area of the risk region in the evening hours, advancing eastward through the night. If we pull a sounding of the environment out ahead of the convection, we can see that there is still a cap in place and that there is some dry mid-level air, but we have some CAPE values exceeding 2000 joules per kilogram. We can see strong surface heating here, as this is around 7 p.m. and we had highs in the upper 80s and low 90s in the area. And there's also a large hail risk due to our instability in the upper levels. Now, with this, it is important to see that our LCL is around the 2000 meter mark or 1500 meter mark, and that storms will probably remain elevated. We also have low SRH values here, but it cannot be ruled out that a tornado could be possible depending on the storm mode, which is expected to be semi-discrete early before merging and growing upscale.
All right, so looking at Wednesday, if we take a look at what the SPC has to say, they're saying that there's going to be a large scale trough with about 40 to 50 knot mid level southwesterly flow that will move eastward from the southwest Great Basin into the southern central plains. And as you can see, they have outlined a slight risk over the Oklahoma Texas border with a large marginal risk all around that area. A lee cyclone will deepen and track eastward through the plains, and a dry line will make little eastward progression over the period. There will be ample daytime heating, and low level flow parallel to the dry line will support some scattered thunderstorm development by the late afternoon as inhibition at the base of the EML erodes. And we can see this on the model reflectivity run. Right here I have the NAM pulled up, and we can see that these storms will start popping up in the Texas around the Texas Panhandle and slowly track more eastward as time progresses. As the enhanced mid-level flow accompanying the trough overspreads the dry line, effective shear should increase to around 40 knots. Elongated hodographs and moderate surface-based buoyancy should initially support some semi-discrete supercell formation with risks of large hail and locally severe wind gusts. As we can see here, they build up and they start moving eastward. Afterwards, strengthening forcing ahead of the trough should promote upscale growth and could develop into a severe MCS. This would favor an increased risk of severe wind gusts with in excess of over 70 miles per hour being possible. A slight risk was added by the SPC because confidence is higher over the west central Oklahoma region into the North Texas region. So as these storms initiate along the dry line and they move their way gradually to the east, they're going to conglomerate into this MCS that we see right here. The front will stall out over central Texas early morning Thursday, but the front will have done its job initiating the convection, and so that the upper level dynamics behind the system will be able to help it move along its way. High precipitable water values near 1.8 inches will pull ahead of the system, and combined with the surface CAPE values in the 800 to 1000 joules per kilogram range and our preliminary 0 to 3 kilometer storm relative helicity values of near 215 meters squared per second squared, suggest that the convection will be deep and able to persist as it continues southeast. Model timings are a little bit off from each other, as the GFS has the system reaching southeastern Texas much earlier and much stronger than the ECMWF and the NAM, as both of these models have it reaching much later, around 18Z. As we can see here, it arrives later and weaker. Me personally, I'm leaning towards a system reaching the southeastern areas of Texas around 15Z Thursday, and they're going to arrive a little bit weaker than what the GFS is predicting. Now, moving on into the nighttime Wednesday, right into Thursday, the QLCS MCS will be continuing to push through Texas, likely remaining below severe status as the environment is favorable to maintain, but not necessarily maintain its intensity due to the low CAPE values, the loss of daytime heating, and weak shear values.
As we head into the later part of the week beginning on Friday, there is still some high uncertainty about the location of the risk region as well as its overall potential. The overall setup will feature an elongated low-pressure system stretching from the panhandle of Texas into Missouri, with a cold front acting as a lifting mechanism, and southerly flow affecting warm, humid air to the north. And the primary risks as of right now appear to be the damaging winds and hail, with the largest uncertainty being the overall tornado risk. This will depend on the overall storm mode and the location of the jet, and whether or not storms will be surface-based or elevated. Comparing the GFS and the ECMWF runs, we can see the progression of our low pressure system and our secondary troughing feature as we move through the time on Friday. Now, the GFS has caved slightly to the euro in the past couple of runs, in where the low pressure system and the trough digs in slightly further south, aligning with what the euro has had consistently over the past several days. This would place our risk area slightly further south in the Oklahoma and potentially North Texas area, but the Kansas and Missouri area also still look very favorable. Now looking at the surface-based CAPE and the photographs based on the GFS, it has our hotspot being more into the Kansas, Missouri, and northern Oklahoma regions. Now, if we pull a sounding from this area, we can see nearly 3,000 joules of CAPE with a very good hodograph for tornadoes along with strong storm relative helicity values. We do have a slight inversion here, but our parcel will be warmer than our environment, meaning that we will be able to lift and generate storms. Now, it should be noted that our surface 6 kilometer shear is also 37 knots, and that we are expecting a potential for tornadoes, but we are not sure about the risk as of this moment, as we are still 5 days out. Now comparing the simulated reflectivity on the Euro, we can see that we do indeed have our low pressure system in the lee of the Rockies, and this will continue to strengthen throughout the day and advance east-northeastward, enhancing our pressure gradient and once again continuing our southerly flow. Now, the big difference between the Euro and the GFS is that the Euro has convective initiation beginning and continuing throughout central Texas, as well as in our risk area up here in Kansas and Missouri. This is different from what the GFS has because it does not have convective initiation in central Texas. Looking as we go forward in time, we can see our swell line developing and our cold front continuing to advance southeastward across the country and coming in much earlier than what the GFS had modeled by about 12 to 18 hours. Now, precipitation also continues for slightly longer than what the GFS has, and not shown here, but the Euro also has a stronger front with a stronger cold blast due to the trough advancing further south. That'll conclude our video outlining the forecast for this week across the country. Overall, high uncertainty does exist within the severe setup for this week, but there is still time to watch it. As we go through the weekend, we'll see another cold blast as a squall line associated with the cold front pushes through the United States. We will keep you updated if anything changes, but that'll be all for now. Be sure to like, subscribe, and leave a comment down below.